Hi Spring fans, welcome to another installment of Spring Tips. Today we're going to talk about Redis. Redis has become an ubiquitous sort of general purpose appliance that everybody has installed or used at some point, and it's made more readily available, not least of which because it's simple to use, simple to operationalize, and simple to install, but because well, first of all, it goes out of its way to be accessible. There's even support, for example, that someone might use it using the Memcached protocol, and the company behind it, Redis Labs, has done a great job of making it as easy to consume as possible on a number of different target platforms. So you can actually use Redis, for example, in Cloud Foundry, right? They've provided the support for that using Pivotal Cloud Foundry or Pivotal Web Services, our hosted multi-tenant cloud platform. Redis Labs also goes, I think, a step beyond. They provide a number of features that make Redis really palatable. So, for example, stock Redis out of the box, the open source Redis, it has a strong correspondence. There's one server, one database. Now, if you want to have multiple databases, then it becomes a little tedious. You have to run multiple servers. They have a product that allows you to then manage all that, right? Dave Nielsen over at Redis Labs, he likes to joke that it is a RDBMS, right? A Redis database management system. In the same way that MySQL or Oracle or Postgres are RDBMSs. But in their case, of course, they're talking about relational database management systems. Now, Redis is most commonly known, I think, for its use as a key value store, but that, I think, dismisses or ignores the large swath of features and functionality that Redis provides. There's a lot of use cases that are well supported by Redis that I think most of us just take for granted or don't even know are there until we ignore. So the goal here in this installment is to look at just this huge, just this amazing, veritable Swiss Army knife of functionality that is Redis, and to see how to build an app with it and see how different aspects of the Spring ecosystem make using it and working with it very simple. So we're going to build a new application here, starting at start.spring.io, and we're going to take advantage of the auto configuration for Spring Boot and Redis. We'll build a new application here called, we're going to call this Redis. So let's see, Redis, like so. And we're going to use the Data Redis support. Okay. Now, you notice that there is actually a reactive variant. We could have used that as well, but I'm going to use just regular Redis. We'll use Lombok. We're going to use the session support. We're going to use the cache abstraction support. We'll use the web support. All right, so we've got a number of different bits here that we want in our application in order to be able to build this application. Oh, we're going to build a web app, so we're going to use Timeleaf as well. So just a lot of different functionality here that we can use to build a very simple application, but we're going to hit a lot of different points very quickly, not focusing on any one particular thing. This is meant to be a smorgasbord of Redis, if you will. Okay, so we're going to build a application here, UAO redis.zip. Open this up in my IDE, and we're going to then move straight into the code, right? So we're going to build a new application. In order to be able to deploy this into, as we will later, into Cloud Foundry, we need to add the commons pool dependency. So I must remember to do that here. Waiting for all the bits to download. All right, pom.xml. Goody. So commons pool 2, okay. And there we are. There's our new server, Redis application. And we're going to build a simple application. So we'll start with what I think most of us are familiar with, which is the Redis template. Now, Spring Boot auto configures a couple of Redis templates here. So let's look at the Redis auto configuration here, and we see that we have two configurations for two different Redis client-side libraries. Now, the other thing you may appreciate is that Redis itself, the Spring Data Redis support, if you look at the Redis template, is very old. Right? This is one of the first modules that we added to Spring Data after Neo4j since the very beginning. I think this has been here for almost got to be 8 years now, right? 2011, 2010. So a long time that we've had this support in Spring Data. It's one of the original modules, and so it's gone through a lot of evolutions. But fundamentally, at the core, there's always been a few core concepts, including this Redis template. This Redis template, very much like other templates in the Spring Framework ecosystem, is a thing that handles tedious resource initialization and acquisition, and lets us focus on the business logic that we want to express. So things like issuing queries and doing updates and so on. are easy to do. They become one-liners usually, and the things that we don't want to waste time on, like setting up a connection and setting up a session and all that stuff, and managing all the result sets and all that stuff, just to be able to iterate over them. All that stuff is managed for us by this template. This template is keyed, it's genericized in terms of the key type that we want to use. So remember, Redis is fundamentally a key value store, but the values themselves can be all sorts of different things. You can have other dictionaries or maps, right? Or they call it a hash as values. You can have a queue, right? So you can simulate pub sub with Redis. You can do, have geospatial indexes as values. You can do atomic numbers and semaphores, these kinds of things as values. So there's a lot of really sophisticated values that you can put there, but ultimately they have a key. And of course, your values could just be arbitrary, blobs of data. And that is the first thing that we have to understand here, is that Redis doesn't care how we encode our data. That data can live in Redis as just a series of bytes, for example. It can live as JSON, whatever you want. It's up to you as the client of that database to specify that when you create the template. Now here, as a quick point, I want to point out there's two different configuration for classes for two different types of clients. So Jedis and Ledis are both two third-party Java clients that can be used to talk to Redis, and we support both of them. We provide connection factories for both of them. So here, we're going to create a Redis template, which in turn injects the Redis connection factory. One of those, it's going to be one of these implementations, automatically. I think there's actually a third one, but there's just no auto configuration for that third one. So we support that. We can configure how we serialize the data, right? So we've got this custom Redis template. Let's go ahead and create our own for now, just to see how it would work. And by the way, you can see down here, we've got a string Redis template. This string Redis template is just a Redis template with keys and values of type string, right? And you can see here that they have already specified serializers, right? So this is a string serializer for everything, right? By default, however, when using Redis with a JVM-based application, you get Java I/O serialization. So the default configuration is Java JDK serialization, which may or may not be what you want. If you're using Redis entirely in the context of a homogeneous sort of Java-based or JVM-based application, then it's just fine. But if you're using Redis with multiple clients and multiple languages, then of course you want to move away from that, and you can. So let's take a look at custom configuration here. Okay, and we'll create a new Redis template, and our Redis template is going to have custom configuration for serialization. So let's say that we have, let's just for now as an example, we're not gonna keep this here, but let's just create a class of type cat, and it'll be string cat. All right. So I want to have a Redis template that lets me work with keys and cat name and cats, right? And so who cares about this type? But suffice it to say, I want this to be parameterized to that. So now I'm going to have a Redis template of type string and cat, all right? And I need to now configure value serializers, key serializers, hash key serializers, and hash value serializers. So in practice, that's actually only just two in this case. So it's a Redis serializer of type whatever, R, new, and in this case, I want to just use a generic Jackson2 JSON serializer, serializing to, or I can even say Jackson, there we go, cat.class. So this is the value, right? We're going to say value, and this can be cat if we like, it doesn't really matter. And then we want to do one for keys. So keys, I think will just be fine with a string serializer. So Redis string, let's see, what do we got? We have a number of different options here. We want the string Redis serializer, that's the type. So string Redis serializer, and we don't need to genericize it, there's no parameter there. So the values, we're going to be encoded with this, and the keys with that. So key serializer, keys, template dot value serializer, values, template dot hash value serializer, values, template dot hash key serializer, keys. All right, so we've got now hash values and hash keys, and just regular keys and values. and we're going to use the same serializer. So this is fine. We could leave this as is, but in our case, we're going to express a number of different configurations beyond just cats, and I just wanted to demonstrate how this would work. And of course, we don't need that. Don't even need it to be public. So that would effectively replace the configuration that we have in the autoconfig if we wanted it to. But for our purposes, it suffices to leave the autoconfig as is. I just want you to appreciate some of the flexibility that you have here in configuring Redis and its connectivity. Now, this auto configuration lets us work with a template, right? We can use the template. So let's do that. We're going to create a bean of type application runner, but we're going to create so many application runners, and I want to be able to, I want to have a way of just sort of setting off each application runner so we can see the examples in the output as we develop today. So we're going to create a little thing here that takes an application runner and then adapts it, and it prints out the title before it runs our runner. So args passing in that, and we're going to inject the log here. We're using lombok to do that, right? So I'll say at log, and I'll say log.info, and then title will be 2 uppercase, and there we are. All right, so there's our titled runner, and we're going to use this a fair number of times. So let's go ahead and build our first application. Our first application using this template. We'll touch on a fairly underappreciated feature, which is that Redis can support geolocation, right? So we're going to say we want to do geography here, okay? And we're going to create some geography. We're going to create a titled runner geography, and we'll create a lambda here, args. All right. Now, this titled runner is going to write data to the database using the this template, this Redis template that we've got here. So Redis template of type string and string is fine for us. We'll use the string Redis template there. RT dot, and then we're going to get the ops for geo. So that's going to give us the geo operations, not the hash operations, not the ones that we can use to manage distributed lists or values or anything, cluster primitives, but instead the geo operations. So I'm going to dereference that, store it in a variable here. Okay. And we'll use the geo. We'll use geo here to record a few records into the database. So I'm going to say add, and we're going to add a record around a city in Italy. This is actually borrowing from the domain inside of the Spring Data, in the side of the Spring Data examples project. So if you go to github.com/spring-projects/spring-data-examples, you'll find a number of different options here. Okay. So we're going to use the point type. Org spring framework data.geo, and this is actually a type that's in the Spring Data framework. And here I'm going to tediously copy and paste, or rather I'm just going to type out loud. So 36138.9, okay, 38.11555.6. All right, and that's going to be REN, okay. That adds 1 point to the geolocation. So it's an index around that key, or near that key, associated with that key, for a city. So here are the parameters. If you look at this, it says we're going to add the key, the point, and then the name of the member, right? We're going to do this 3 more times. The second time we'll point to 1508 7269 37.502.669, and this place will be called Catania. And here is the second example, the third example rather, 13.58, and then it's 4 threes, I think, right? So that'll be fine. And then it's 37.31667, okay? 7. So I think that's right. Let me just reconfirm here, just revisit these numbers. 13361.389. 13361.389, okay? Good. 3811 and then 5556. So 3811, 555, and then 6. Good. Second set is 15087269. 15087269. Good. 37 502669. 37 502669. Great. Next set is 13583333. So that looks correct. 37.31667. 37.31667. Good. So we've got now the correct data. Now we're going to use that to create a circle. We're going to draw a circle around one of these points and see what falls within that circle. So we're going to say new circle, new point. Okay, and we'll use 13.58333 37.31667. So 155833 37.31667. Good. And we're going to tell it to specify a distance of that, around that point, using 100 kilometers. So Redis geo commands dot wrong one. It's the other one. Dot distance unit dot kilometers. Very good. So there's our circle, and now we're going to use Redis to ask it what points fall within that circle. So we can say geo results, or actually we can just say this dot or geo dot circle radius, and we're going to ask it for all the things in that radius. We're going to say within that key, and then we'll give it the circle point here, and that'll give us a collection of geo results. All right, so now we can visit each one of these geo results here. Let's see, it's going to be geolocation, and the results we're going to visit. We're going to visit each result dot for each gr log.info gr.toString. All right, so we can get the content. I suppose actually it might be even easier. Let's do that. Geo results dot get content dot for each. Okay, so c log.info c.toString. Let's see what that gives us. Let's run this program and see. All right, so two of those points fall within that region, Palermo and Gento, something like that. All right, very good. So that's a simple example, but it works, and obviously you wouldn't hopefully have this hard coded. This would be something you could load in from a GIS database or something like that. But a lot of possibilities here, right? You can do some very, very, very quick work with geography here to support common geospatial kind of queries that you may want to support in your application. Now that's one common use case. It's a very common use case is to use geography to work with geospatial data, and it's just one of those many things that Redis does. It just does it well. And while you could use PostGIS or in the Postgres world or MongoDB or Couchbase, they both have geospatial support as well. If you've already got Redis, you might as well just use it, right? So that's one of those many things that you can just do out of the box nicely. Now let's talk about one of those other things that template supports, right? We saw that the Redis template supports rt.hashes, right? So hash ops for hash. And hash gives you hash operations. And what this lets you do is create a map that's associated with a key, which is great. So you have the ability to store basically records. You can store a whole record associated with a key. You could say, here's the whole, the first name, the last name, and the email and the ID for this username or whatever, or even just look it up by the ID. So that's a natural thing to use to store records. And in fact, we can support repositories. So another concept, another tenet of the Spring Data projects is this concept of a repository. Now, a repository in Spring Data is just a conventional configuration-centric approach to building queries based on the names of methods in interfaces. And Spring Data has a number of different implementations that work with different projects, and these are meant to support as much as we can, but no more. We're not trying to provide the illusion that certain things are possible for things that don't support it. But we can actually make basic CRUD style repositories work with Redis. So let's do that. Let's create a simple type here called a order, and it's going to be serializable. And we want the order to support an ID. So we'll say private long ID. So we're using the Spring Data ID type there. It's going to have an indexed date, right? Indexed private date when. All right, w date, and we'll have a reference to a list of line items. All right, so line items, very good. Now this type, of course, we need this type class line item, implement serializable, and we'll come back to what that type does, but for now, we know that this type, our type is going to support, it's going to be persisted in the database using Redis hash functionality here. We know that we need getters and setters, so I'm going to say at data and all args constructor and no args constructor. You don't actually need the no args constructor for Spring Data. It's not like JPA where you do need it, but I want a no argument constructor, right? Because it's just convenient. So these are all maybe optional. But that said, good programming practice says that if you want to have a validly constructed object, you should learn how to be able to construct that through the constructor. So maybe I don't need a no args constructor. Let's just leave it for now, okay? Now, I have a order, not quite what I wanted. So order there, and the order will have line items, and the line items will have at indexed a private long order ID. All right, and we'll have an ID here at ID, private long ID, and that's it, private string description. Now, we want the line items to be persisted as well, line items, and it's going to have all the same things as before. Now, we need to create repositories to persist this. Now, when we say indexed, index means that it's going to create a key. It's going to be able to. I'm going to be able to look up this record by this value as a key, sort of, right? So it's going to create a customized. It's going to create an extra slot that I can then use to quickly reference this type by this value, and we don't have to worry about that too much. But this is critical when you're using Redis. These types here, Redis hash and add index, are specific to the Spring Data Redis support. The ID annotation is generic to the Spring Data ORM abstraction, the mechanism that underpins this. But we went out of our way to make this work for Redis, and it's very valuable, right? It gives us the ability to model complex things and still do so in an efficient way. But that said, we don't promise that we can do certain things that are just not reasonable for something like Redis, which doesn't support perhaps sort of the ad hoc query support that you might expect if you're using MySQL or something like that, right? So line item, going to manage line items whose primary keys are type long, and interface order repository is going to extend CRUD repository whose payload of type is order and ID is long. All right, so there's our two types. Now maybe I want to have a custom finder method here. Let's say I want to do collection. Let's say I want to find an order by its date. Find by when, right? So date D, and I can do that. That works actually just fine with our Redis abstraction here. So let's say we want to create some data. We have to create an application runner that supports this data. So Redis, repositories, and we'll say return titled runner repositories args, and we'll go ahead and run that. And the repository, we're going to write some data to the database. We're going to have a couple of records. We're going to see, well, first of all, I need to create an order ID. So long order ID, and I need to generate a ID. All right, so I'll create a convenience method here because I'm going to do this a lot today. So we'll say long temp equals new random dot next long, and that may be negative, so I'm going to say math dot max temp, or temp times -1, and I'll return that. So there's our generated ID, and what I want to do is I want to create a few different line items, and I'll save those first. So arrays dot as list new line item, order ID, generate ID, and I'm going to call this a plunger, for example. And a new line item will be order ID, generate ID, soup. And a new line item will be order ID, generate ID, and you know, what's a good one? A coffee mug, sure. All right, so now we've got these types, got these records that we're going to save to the database. So we need to actually visit each one and then save them. So I'm going to say item list dot stream dot map. I'm going to pass in the line item repository. So let's do that here. So line item repository, and here I'll say repository dot save it, and it is of course the generic there. Replace it with a method of reference if we want, and then we need to subscribe. So we need to actually visit each record that comes back, and we'll say for each li system out. I guess we can just use log, right? No problem. Li. So li.toString. Very good. Look at that. We've got now these different records, and that should work. Let's go ahead and run this, see what we get. Okay, so those are the three records after they've been saved. Now let's create the order. Order equals new order. Here, the order ID, we'll pass that in directly. The new date will be this one right here, and the item list will be this. And now we're going to save this as well. We're going to say to inject the order repository. So order repository, and I guess I can rename this to line item repository, and we'll say order repository dot save order, and that will give us a result that's been saved in the database, and we can then inspect it. We can say order repository dot find by when, where order dot get when. So this should return, if everything goes to plan, retrieve, found, and it's going to return a collection, I suppose. Or we could even do an optional if we wanted to. We could have said optional of t, find by whatever, if we know there's only 1 or 0. So there we go. So we've got that now. And let's just visit those records. So we'll say found.forEach, o log.info, found o.toString. All right, so I'm visiting the data that's coming back from the database after I'm querying it, after I've written it to the database. So we're going to run there we go. So we wrote it to the database, we found it, got this record back, and of course we got the referenced line items therein, right? So the description is the plunger, the soup, and the coffee mug. All that is just being done for us automatically. Now if we look at what's happening behind the scenes here, in Resolve, you can see it's actually created a whole schema that's managing all of this for me, right? It's just managing it for me. I don't have to worry about it. And it's got indexes, it's got the relationships, it's got all these keys, orders, when, etc. Right? So all that is being done for us. So we don't have to worry about, any of this kind of complicated stuff. Redis is perfectly happy to do it. It's just that there's a little bit of manual assembly required here, and the Spring Data abstraction does that work for us, so that we can now get the best use out of Redis here. Okay. All right, so that's a very simple example. That's just we're using hashes behind the scenes, right? This is actually fundamentally turning into things like hashes and keys and values. It's using the fundamental atoms of Redis, but it's doing something very sophisticated on top, which allows us to focus on higher order business logic concerns. So the next thing that we want to focus on when we look at in our little tour here of Redis is using it for publish subscribe, right? This is a common use case. I want to communicate from one node to another using some sort of middleware, where I could, of course, install Apache Kafka or RabbitMQ, and these are both fine choices. Maybe even a JMS broker, although there are reasons why you might want to avoid that last one. But Redis is actually, it's fine. It's not the most featureful message broker in the business, but if you've already got it installed and you're trying to do simple pub sub, then this might be all you need, especially if you're just doing status updates where it's fine that you might lose a message here and there, right? If you're trying to do financial transactions, then yeah, okay, probably probably better to use something like RabbitMQ or Kafka, right? But here, we're just going to create, let's suppose we have a chat, right? And we want to, or status notifications, or presence awareness, or something like that. This is a perfectly fine choice because it's going to be in memory. It's going to be lightning fast, and clients are going to be able to, publish messages to a topic, which is actually just a key, and with a queue behind the scenes, and then they can consume it. So we actually have support for this in Spring as well. So let's create an application that sends a message. So here I'm going to create an application runner, bean application runner, pub sub, and we're going to return a titled, so publish subscribe, okay, and scribe, there we go, args, and we'll use this publish subscribe endpoint, use this runner to now send a message, and that's the easy part. I mean, both producer and consumer are easy, really, but we're going to use the Redis template here. So Redis template of type string and string, RT, and we're going to say RT.convert and send, and we're going to create a channel here, a shared channel, a topic. So private final string topic, I guess, whatever, who cares, chat, okay? And I'm going to say that I'm going to send a message to this topic. So topic, and we can just, there, okay? And the message I'm going to send is any arbitrary message. And here, it could be, it could be JSON encoded, it could be a string, it could be whatever you want. So, but we're relying on the default string serialization here. So I'm just going to send a string, hello world at instant.now.toString, all right? So I'm sending a time encoded message. And now I need to consume that message. Now I could spin up another node and it would be very easy, but since we already understand how that would work and I want to save myself some typing time, I'm going to go ahead and create a message listener consumer here in the same node. So I'm sending a message into Redis, and it's going to be delivered right back to the same node, which is acting as a client. So it's making the same network hops as it would were it to actually be two different projects. But I just want to demonstrate how this works. Okay, so let's now create a message listener that's going to respond to messages. And in Spring, we have this concept of a message listener container, right? So a message listener container. I'm going to use the Redis message listener container, and this Redis message listener container needs a message listener. So let's create the Redis message listener container, like so. And the MLC needs a connection factory, of course. So we'll inject the Redis connection factory. All right, and we'll say CF, and we'll say MLC dot. We need a message listener, right? So we need to do that as well. And the message listener will be ML. We'll come back to that in a second. And then we need a pattern topic. So I'm going to tell it to use this dot topic, right? Same as before. And that's it. That's the MLC itself, but we need the message listener. So let's do that. That's the easy bit, right? So ML equals new message listener, very simple interface. And here, we're going to take the data from the payload and just log it out, right? Just confirm that it's as we expected it to be, and enumerate the value, right? So let's do that here. We're going to say string equals a new string message dot get body. Those are the bytes that come in, and we want to log it out. So log.info new message or message from, okay, and it'll be this dot topic, or it'll be topic, okay, str, very cool. Now we can use that message listener. All right, good. Replace it with a lambda. So there we go. So there's our message listener container and our incoming messages, and we can now read the data. Let's see what happens. So let's go ahead and run this. Now keep in mind, this message is going to be received asynchronously, out of band. So we're going to see the header for publish subscribe be printed And it might actually, let's see, publish subscribe gets printed. Where's the result? Found. Did I do something wrong? Message listener container. Message listener. Message. Return the container, return that. I don't see it doing, I see it doing this, don't I? So there's the publish subscribe endpoint. And did I do it the wrong way around? Convert and send to the topic, hello world. Yeah, that looks right, doesn't it? So, how is it? I'm missing something obvious, clearly. Publish subscribe. And the topic, let's say it's called chat. Log.info. Can we try this again, this time with the debugger? Let's see what we get. It's not quite working the way I expected it to. So let me see. It's a message listener container. Redis listener. There is the name of the bean. I was some other bean was conflicting with that bean type, so I renamed it to listener, and I got message from chat, hello world, blah blah blah. Okay, so that actually worked. That was a mysterious one. So there we go. I guess we just learned something new. Don't use the name that I just had before to name your container, but once you do this, once you've changed it from that, it'll work. So here we go. We have a message listener container that's responding, or that receives the incoming message, and it can do something with it. So now you can do all sorts of interesting things here. You could create topics based on, so this thing here is a topic of some sort. You could create a topic that has a unique key that only one producer and consumer would agree on. You can do broadcast them. You can do all sorts of things, here with this basic messaging primitive, right? So this is yet another thing that's kind of just supported out of the box. It's a little known feature of Redis that I hope you'll take advantage of, right? We also support using Redis for keys and values naturally, and there's a lot of different places where you would want to do that, including in caching, right? So when you cache data, let me move this code to the top of the code page there. There we are. And what we want to do is we want to cache data that we've created that's perhaps expensive to arrive at. So let's say at enable caching at the very top here, right? So at enable caching, and in our build, you will see that we have here. In the build, we have the Spring Data Redis dependency, and that dependency has a cache manager abstraction. So it's going to work in conjunction with the @enable caching annotation. And for it to do its work, it's going to need a cache manager implementation. And we can configure that fairly easily. So let's do that here. We'll say @bean, well, I guess we can do it here. @bean cache manager Redis cache, okay, and we'll create the cache manager, and we're going to say return new, we're going to use the Redis cache manager builder methods here. So Redis cache manager dot builder. I'm going to inject the Redis connection factory. We'll say builder.cf .build. All right, so there's our Redis cache manager abstraction implementation. And now we can create something stateful that has that's potentially imperformant and expensive, and we want to be able to memorize or remember the results of a method invocation. So I'm not going to do the goal here is not to do a whole introduction to the cache manager abstraction, although you should absolutely look into it. But instead, I want to create, I want to demonstrate how this works seamlessly with Redis. So I'm going to create a order service, let's just say, okay? So an order service, and this order service is going to be cacheable. So we're going to support caching results that come back from this method. So public order by ID, looking up the ID here. I'm going to say @cacheable, and we're going to say order by ID. So it'll look up the records from this method. It'll take up look up in Redis any of the data that comes from this. Let me try that again. When you call this method, it's going to see, first of all, if there's a result already stored in the record, in the database, with this key and another key that's, a combination of key based on this name here and the arguments to the method invocation. And there are arguments, there's annotations that you can use to control, which keys should be used and which invocations should be used to evict data from the cache. But let's just assume that we want every argument there to contribute to the key that is then used to return this resolved result. So now let's say return new order, passing in the ID and a new date, and we'll just pass in an empty list of line items there. Now what we're going to do is we're going to create an artificial sleep. So it'll take a solid second. If somebody wants to call this without having it already in the cache, and then otherwise, let's just make it 10 seconds. That way it's actually perceptible. Okay, so, and then otherwise it'll just go straight to our Redis cache. Okay, so let's say @log, and we'll say log.error info, I guess, exception. Actually, it doesn't even matter. Let's just do throw new runtime exception E. All right, so I don't even care about this. Don't even need the logs. So we're creating an artificial. We're just returning a result. Who cares about the result? But we want to induce that artificial sleep to make sure that we can see how fast it's going. So now let's call that order service from a repository, from a runner, and prove that it's working. So let's create a new bean of application runner. So cache, and we'll use this order service, which has been created for us. Order, what did I save it as? Order service. I am not doing great with that word today. So order service, and titled caching a good. So there's this, and in the order service, we're going to call the method, but we're going to do so a number of different times. So what I'm going to do is I'm going to measure each invocation. So we'll say runnable R. How are we going to do this? What's the easiest way to do this? We can create a method to save the, let's see, class. Yeah, private long measure, and we're going to take a runnable R, and we will save the current time. So start equals system.current time milli, long stop equals system.current time milli, and we're going to run r.run, and What is that about? Private. Okay, and we're going to return stop minus start. So that's the measure method there. And we're going to measure some runnables, and the runnable is going to be measure, it's going to be this. So we're going to say run order service dot by ID 1L. All right, so now I'm going to print out the timings for that. So let's say we have log.info first, and we'll print out measure. Okay, so 2 times, 2 and 3 times. So we'll have now 3 invocations of the same basic thing. It's going to run this invocation each time, and we'll see the results, hopefully, right? So we'll say, call this, and then show us what we got. So now let's see, why is this still upset? Oh, that's because of the inspection, disable that inspection. Okay. Now let's go ahead and run this again. This time we're going to run, it's going to be called caching. We're caching the same lookup. The first time it should take, whatever we said, 10 seconds. So it's calling caching. Taking its tedious amount of time here, of course. There we go. So the first time it took 10,009 milliseconds. 10 seconds and 9 milliseconds. So the actual access on the first time was 9 milliseconds. The second time it took 2 milliseconds, and the third time it took 1 millisecond, or less than. So this could actually be nanosecond granularity at this point. I don't know. I've just got it. It's giving us it's rounding up, of course, right? So the point is we have the ability to go really quickly if we're using memoization, right? And we get that for free. And behind the scenes, if we look at this keys, we have invocations based on IDs in there. So let's see. I'm not even sure if I can spot the invocation, the incantation that's being used to make that call, right? So orders. I wonder if it's that one. Well, anyway, that's being done for us automatic. Oh, there it is. Order by ID 1, right? So that's the incantation. And if we look at that, value, orders. Okay, so keys and get value. Let's read. Okay, so we're trying to get the value for a key, and if I'm honest, I don't know the command that you're supposed to use in the Redis CLI. I just always do it from Spring. So is it get key? Let's try get something. There we go. That makes sense. So paste. There you go. So there's the Java serialized encoding of that object. Again, you could use a custom serializer, but you can see it's got the same information that we need. There's the order and the line items and all the bits that are required to make this work. The Java util date, all that stuff is there. All right. Okay, so there's the memoized version of the record, and that would work. Serialization issues notwithstanding, that would work across multiple virtual machines as well. So if we have 10 different applications, web applications, and they're out there making calls to this order service, and one client makes a call on one web service, one application instance, then other clients accessing the same record on other application instances would benefit from that lookup. And of course, you could have cache evict annotations to evict. You can say public void update long ID, and you can say cache evict this record based on this method call. So we would actually invalidate the record in the repository based on the call. All right. So now, speaking of web, another very logical sort of use case for a cache like Redis is to use it for session storage. Right. So let's bring that application back. Oops, Redis application. We've got this application now running, and the application's running, and we've got no web endpoint right now. So let's go ahead and do that. We're going to build a simple web endpoint that's going to use the HTTP session. So we'll say, what do I want to write? I can do it in here. Let's say class session, cart session controller. All right, and this is going to be a logged and Spring MVC controller that's going to have a session attribute called cart, and we'll come back to that in a second. And the data, we're going to create a model attribute. So what's going to happen is we're going to return a shopping cart. Okay, so class like so, and the shopping cart will have a collection of orders, and this has to be all serializable. So you should probably use a little bit more care here, but I'm going to be using a very simple, sort of thread naive approach here. So I'm going to say public void add order. I'm going to use an order object here. So order, and this dot orders dot add order. Good. And we're going to have another endpoint here that returns collection of order, get orders. All right, so return this dot orders dot, there we go. So that's my very simple shopping cart, and we want the shopping cart to be persisted, so we're going to make it serializable as well. Okay, and we want to support, where's my formatter on? That explains part of the problem. So now let me confirm that's working. Good. All right, so there's that. This is session attributes. Good. So what's going to happen is when this Spring MVC controller gets loaded, there's going to be certain endpoints here that are going to look for a cart. And they're going to look for the cart in the session. If they don't find it, they're going to have to create a brand new object that they can use as a backing bean for data that's going to be created in the lifecycle of one of these handler methods. So it's going to look to a model attribute method on the controller to vend a new instance of that cart. So return new shopping cart. So this is going to be empty. I'm going to log, producing or creating new cart. All right, I'm going to log that, and then I'm going to use it. I'm going to say let's create an endpoint here called orders dot Redis or whatever, just to call it orders if you want. That's going to return an HTML page rendered with time leaf, and that's going to inject this model attribute. So model attribute cart, and it'll be shopping cart. So shopping cart, and we're going to create a model, a Spring MVC model to render the view here, and the model is just going to have some data in it. Model add attribute orders, and it'll be cart.getOrders. So this, what we're going to do is whenever somebody goes to this endpoint, we're going to add a new order, and we're going to have a private atomic long, right? So private final atomic long, new atomic long. I'm going to call this IDs, and we'll add the order here, like so. We'll say id.increment and get new date and collections.empty list. So we're going to add a new record each time and then render a view called orders that has an attribute in the view called orders that we're going to iterate in the view. So to review, somebody's going to call this endpoint. We're going to add a new record to the cart in the session. If the record doesn't exist in the session, then it's going to call this model attribute method, and then it's going to use that. It's going to be injected here as a parameter, and then we're going to add a new record. So over time, given the same session, we should see an increasing number of orders in the cart. But if you start a new session, it should be set back to 0, and we should see it saying creating a new cart, right? So first time, it'll call that. Okay. Now we need a template, some sort of view. So this is why I added time leaf here. So source main resources templates. I'm going to create a file here called orders.html, and the orders.html file we're just gonna I'll spare you all this live coding there. So desktop, Redis, source, resources, templates, orders.html, clipboard. Good, right? So there's that. So very, very simple Redis orders, right? Redis orders. And what we're going to do is we're going to render a div element, or rather we're going to render two spans for every order O in the orders attribute from the view, from the model rather. So we're going to dereference the ID and the when attribute, right, in the order. So I think that should be it. The only thing we need to do now is to enable Spring Session. Spring Session is the facility that lets us swap out the HTTP servlet session and replace it with a pluggable session store of our choice. And here we're using Redis. We could use EHCache or in-memory, or we could use MongoDB or JDBC or Hazelcast, or a number of different options here. But Redis is a fine choice for this. So we're going to add Redis sessions and restart the application. So now, if we go to, where did we say? We're going to go to /orders in the browser, localhost 8080 /orders. There we go. 1, 2, 3, 4, 5, 6, 7, etc. Now, if I create a new instance, go to the same endpoint, you can see it's got this, it's this ID is number 9, so it's obviously a different instance, but it's increasing, independent of each other. So, right? So I've got two different sessions here, and that state is being stored in Redis. So keys, and you can see it says Spring Sessions expires, and there's another attribute in here somewhere. If I could, there's Spring Session expirations, Spring Session, etc. So we've got different sessions being persisted here and managed for us by our different application instances. So if I were to spin up another instance of this application in this, and then somehow call that application on port 8081, for example, then given the same cookie, the same client-side cookie, I should get the same result, right? So there we go. That's that's a very simple example of using Redis as a session. It's just pluggable. Where we could actually inject the. I'm using Spring MVC here, but you could inject in your Spring MVC controller. You could say HTTP session, and then do that as well. It'll work, right? It'll plug in to the Spring Session adapter that we've automatically configured for you. So that works, independent of the programming model here. You could actually create a web servlet at web servlet annotated component, straight up a servlet, and then that would in turn also delegate to Redis here. So that works at every tier, and it just happens for free. So now we've got horizontally scalable session persistence, which means that if a node falls down and they get load balanced to another node, the session state hasn't been lost, right? Okay, so now that we've got a web application, we've got a number of different use cases demonstrated here. I think we should deploy this. All right, so I'm going to take this application. I'm going to add a Cloud Foundry manifest to the application. So cd Redis, copy desktop Redis manifest here, and you can see that if I look at the manifest says that the application is going to be called Springtips Redis, and it's going to use a backing service of type Springtips Redis. And again, I'm using Pivotal Web Services here, and I can go to CF Marketplace, and I'm being given all the different service offerings for this hosted multi-tenant cloud offering, kind of like Heroku or something like that. And we have here a Redis instance. Where's our Redis support? New Relic, no, PMySQL, PQ, Redis Cloud, voila. So there's our, different quotas, different SLA options here, and I've got a instance of this, CFS, which is short for service. I've got an instance of this, ST Redis Cloud, 100 megabyte plan, and I've got an application called ST Redis. I'm going to now CFD -F ST Redis. Okay, so I'm deleting the application. That's already been deployed. So it's now being unbound from the Redis instance. And I'm going to delete the service. I'm going to delete CFD -DS -F ST Redis. So I'm deleting the service as well. So now we'll have a brand new everything. I'm going to create the service anew. So CF CS ST Redis. It's going to be Redis Cloud, 100 megabyte ST Redis. Okay, so there we go. And now I'm going to do a Maven clean package. And that's going to build the jar, the application, the Spring Boot application. It's going to run the application, so we'll see all the same familiar logging that we saw when we ran the application in the IDE. And then we're going to deploy it to the platform. All right, so now we say cf push -p target Redis, and we're going to give it a logical name called st Redis. But we could, I think it'll automatically I think it'll merge this push command with the manifest. But let's just, I think it'll be fine. Let's just try it. Creating app st Redis, using route, binding this route to that, uploading this. I'm not sure if we've already bound the st Redis to it, or if it's going to consult the manifest. Oh yes, it is. Look at that, using manifest. So it has already bound the service of the names st Redis to the application. So now it's uploading the application. It's going to the platform is going to look at the incoming artifact. It's going to realize that it's a jar application. It's going to give it a file system that has everything needed to run the application. In this case, a Java virtual machine. It'll give it a route, which we saw here is stredis .cfapps.io. And let's see what we have here. So it's going to use a build pack. That's the thing that decides what file system is required to run the application. It's going to choose inevitably the Java build pack, and it'll start the application up. It'll turn that file system into a container that it'll then schedule across the cluster. Now, what we can do is we can actually cluster our application. We can say cf scale -i 2, and effectively double the number of instances of the application itself, but they're both talking to the same persistent Redis store. So even if we hit different instances of the application, we'll still get our data. Okay. So let's see. Waiting for the build packs to kick in. Good. Creating the container, uploading the application. Now the artifact should hopefully spin up here any moment now. Upload complete. Uploading complete, not sure exactly what that is. 0 of 1 instance is running, 1 starting. There we go. So there's our application up and running at this endpoint. Let's try it out. Okay. And it's called orders, right? So first call, second call, third call. And do the same thing here. Right, so now we've got an application, two different sessions being persisted. Now let's actually go ahead and scale this up. Okay, so cf scale -i to st-redis. So I'm going to double the load on that application instance. Cf logs. I'm going to follow the logs now for this instance. So as I make requests over here, you can see the request coming into the application on the left. So router 11, router 0. Let's see, where does it actually indicate the so the other application is still coming up. App proc web 1, good. So we got now 2 different apps being configured. We'll wait for that to spin up, and we'll start to be able to round robin the requests across multiple instances. All right. So okay, refresh. Notice how, in this case, since we're running, we have the same session, but it was handled on a different JVM, and we know that it's been handled on a JVM because the ID is 3, right? So remember, we have that private atomic long. Well, this is JVM specific, it's intrinsic state. But the internal state, the external state, which is the session itself, that's being managed by Redis. All that's just transparent. So, we have the same host, and we have the same HTTP cookie, the same session cookie. It's hitting the same host. We have a load balancer behind the scenes, and we're getting different sessions, right? We're getting different application instances. We know that because the application state is different across those different JVMs. But we are still able to see and work with the same shopping cart on both nodes. So this is one of the examples of Redis just being a transparent, thing that you can just layer into your application and get all this amazing functionality. Now we've looked at a few different things here. We looked at caching. We looked at Redis HTTP sessions. We looked at repositories. We looked at geography, geospatial support. We looked at publish subscribe support. We looked at caching, just generic caching itself. We looked at a number of different things here, but we've only begun to scratch the surface. Redis is, as I say, a veritable Swiss Army knife of functionality. It supports a number of different things, and in the Spring ecosystem, we use it to great effect at every layer that we can. So we even have a project called Spring Cloud Gateway. It is built on top of the reactive support in Spring Framework 5, Spring Web Flux, and all that. And I've done previous videos on Spring Cloud Gateway itself, and there we looked at using Spring Cloud Gateway to create a rate limiter. Well, it has to keep external state, extrinsic state somewhere, so it stores that in Redis, for example, and that's actually using the reactive Redis Spring Data module, which I haven't even bothered to use here because it's still just, all these ideas apply. It's just very convenient to know that you can use this in a traditional servlet-based architecture as well. So, with that, my friends, thank you so much for watching. I hope you enjoyed, and we'll see you next time.